This is going to be notes 3A on fusion, starting our new unit on energy, unit 3. So the first thing I want you to do is to do the quick review up here at the top. You're going to pause this video. You're going to use the word bank here to fill in those blanks. When you think you've got it right, or when you at least have a couple of them filled in, unpause and then check to see if you're right. Okay, you've unpaused. Now you're ready. Here we go. A physical change is one that does not make a new substance. It may change shape or perhaps melt into a liquid or freeze and form into a solid, but it is still the same substance. A chemical change is one that makes a new substance. A solid, called a precipitate, may form. Also, a gas may be produced, which might be observed as bubbles in a liquid. There might be an odd or even bad smell, and you might even see smoke. How'd you do? Good job. Okay, moving on. So just like all the other notes, if I'm going too fast, pause it. But I'm going to go pretty quickly so that this video doesn't last forever. So like many other stars, the sun is made of mostly one element, hydrogen. It exists at high temperatures and pressures, like 15 million degrees Celsius, like exceedingly high, stupidly high. So what state of matter is that going to be? I want you to pause and answer that question. That's right. It's plasma. So we talked already about that. The plasma is the state of matter that's in the sun. So what goes on with this state of matter? What happens with plasma? What's it like? We know that solid, the molecules are tightly packed. With liquids, they flow freely. And with gases, they collide and fly all over the place. And we know that with plasma, that's right. It's an atom with no electrons, and the nuclei are all squished together. So an atom with no electrons, and the nuclei, that looked like a D instead of a C and an L, nuclei squished together. All right, again, pause that if you need to, but I'm clearing it and moving on. So which subatomic particles are inside the nucleus of the atom? Circle it. That's right, protons and neutrons. And then what charge does the nucleus have? So since the nucleus has protons and neutrons, electrons are negative, neutrons are neutral, so the only charge we're going to experience is the positive charge of the protons. So normally, like charges repel. So normally if you put like two north ends of a magnet together, they're going to push away from each other. But in the sun, where hydrogen is in its plasma state, the positively charged nuclei are close enough together and moving fast enough to collide. So just like gas particles smack into each other, plasma particles smack into each other. So when the colliding nuclei have gathered enough energy, they can fuse or join together in a process called nuclear fusion. So fusion equals join equals combine. So if you live in an older house, you might have the type of fuses where when the fuse blows, you have to actually unscrew it and then put in a new one. And if you look at those, there's a little metal strip across them. And when one's been blown, that metal strip has been melted through. When it's a good fuse, the metal strip is complete. So fuse combines the two sides of the electric circuit. When it gets burned through and it's not fused together anymore, the fuse has gone bad. It's not fusing anymore. So fusion, join, combine, come together. In nuclear fusion, the nuclei and that's just plural for nucleus. So nuclei just means more than one nucleus. They combine together to form a new, larger nucleus, and it releases tons of energy. Inside stars, like the sun, nuclear fusion combines small nuclei into larger ones, creating heavier elements. So this is where at least some elements are made. So you wonder, where do these elements come from? Well, at least some of them are made in stars, like our sun. So inside our sun, hydrogen, existing as plasma, collides and combines to make another element. So hydrogen has one proton in the nucleus of one atom because it has an atomic number of 1. So if the nuclei of 2 atoms of hydrogen combine, which is nuclear fusion, how many protons will be in the larger nucleus? So we have 1 hydrogen, and they smack together. How many do we now have? 1, 2. So what element did we make? What element has an atomic number of 2? Right, helium. And why helium? Because it has 2 protons. Again, if you don't have that yet, pause it, but I've got to move on. All right, so here is a basic drawing of what happens in fusion. Now, notice that says D, and we've got 1 proton and 1 neutron. Well, what element do we know has 1 proton? Right, hydrogen. So how in the world is it D? Well, because hydrogen has so many isotopes that are so commonly used, each isotope has its own name. So hydrogen that has 1 proton and 1 neutron, that particular isotope, instead of the isotopes of hydrogen that have no neutrons, or the isotopes of hydrogen that have 2 neutrons, and that's called tritium, the ones that have 2. But this is deuterium. D-O-D-E-U, meaning like deuces means 2, like peace out, deuces. So it's, or in a card deck, deuce is the 2. So deuterium means it has 2 particles. Tritium is the hydrogen atom that has 3 particles, but it's still hydrogen. So that's what that is. It's deuterium plus deuterium, but it's still hydrogen plus hydrogen. And so our 2 hydrogens combine, and when they do, they release a lot of energy, and that's like the universal symbol for energy being released. And then we get 1 atom of hydrogen and then an extra neutron that's floating around, and it'll find its way into another atom sooner or later. So what is the major fuel of the sun that provides the energy needed to sustain life on Earth? What is the element that is mostly doing its thing in the sun? Hydrogen. So hydrogen, the fusion of hydrogen into helium in our sun is what keeps us alive. So what's really amazing is in this star, which is an element factory, as more and more helium builds up in the core, the sun's temperature and pressure also change. So because the sun is now hotter and under more pressure, different nuclear fusion reactions can occur. So over time, we could have 2 heliums that are floating around and they get smacked into each other. So what do we have now? We have 4. So that would be, that's right, beryllium, because that's the element that has an atomic number of 4. So 2 protons in helium plus 2 protons in helium gives us the 4 protons in beryllium. All right, well, what if we've got our beryllium and then another helium comes along and smacks into it? Now we have 6. So another helium nucleus joins the party, and we now have, that's right, oxygen. Because we had our 2 protons in the helium plus the 4 protons in the beryllium gave us the 6 protons in, oh, not oxygen, carbon. Oxygen's 8. My bad. You're going to fix that. Carbon. Sorry, it's the end of a long day and the end of a long week. You understand. 6 protons in carbon. There we go. And yet another helium nucleus can join the party. And now we get our oxygen. So 6 plus 2 is 8. And now we have oxygen. So we have our 2 protons in the helium plus the 6 protons in carbon gives us the 8 protons in oxygen. And again, pause it, but I'm clearing it. So stars the size of our sun do not have enough energy to produce elements heavier than oxygen. So our sun is relatively small when it comes to stars, and it can't make any elements bigger than oxygen. Okay, well, where do the rest of the elements come from? Larger, hotter stars. Oh, larger, denser? We'll have to look up and see what I'm supposed to write there, but denser is true. So larger, denser stars become even hotter than the sun. These stars have enough energy to produce heavier elements, such as magnesium and argon. I mean, pick any of them, really. Some even have enough heat and pressure to produce iron. So even your biggest stars, iron is the heaviest element it can produce. But that's only element number 26. So where do the rest of them come from? If we have up to 118, or at least up to 100, at least up to 92, because those we know we find naturally, but 26 is the biggest that happens in a star, where do they come from? A thing called a supernova. So a supernova is a tremendous explosion that breaks apart a massive star, and it produces temperatures up to 100 million degrees Celsius. Like, that is so hot we can't even contemplate it. Supernova provides enough energy for those heavier elements. So all of the elements larger than iron, when they were created by a big star dying all at once. A big explosion. And it just seeds the universe with elements. And elements just get spread out all over. So everything around you, the air you're breathing, the pencil you might be holding in your hand, the computer you're holding in your lap, the table you're sitting at, the clothes you're wearing, even you, is the stuff of stars. So no matter what you're talking about, it at one point was made inside of a star or a supernova. So just think about that. All right, don't forget to watch the video that I've posted about supernovas so you can see what I'm looking at. It's pretty cool to watch. But other than that, have a lovely day. Make good decisions. Bye.